Okay, now we're to the point where we're going to actually be calculating and interpreting confidence levels. So you recall in the last video we had the model with the mean, the critical value, and the standard error. Well, the reason we have all those is we need them. Now, all of those can be calculated through your calculator. So once we have those calculations, we can determine the confidence interval, which is the mean plus or minus your critical value times your standard error. Again, remember your standard error is going to be the standard deviation for the sample divided by the square root of n. And t, the critical value, depends on the particular confidence level and the degrees of freedom. So in this example, we have a coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts measured in a random sample of 20 cups, and we want to create a 95% confidence interval. So here are the 20 cups. All right. So first of all, we have to look at conditions just like we did before. Is it random? Well, it's given in the problem. It says a random sample. Independence. Well, it's reasonable to think one cup does not influence the other. And is it normal? Well, let's take a look at the histogram. What I did is I put the data into the calculator in a list, and I would strongly recommend you do the same. And then I went and graphed a histogram. So I'll try to put a link up so you can remember how to graph histograms if you're rusty. One caution, when I graphed the histogram with the default windows, there was a little bit more of a bump there, not much, but it was more unimodal with a bump on the left, maybe a little bit more skewed. When I changed the window to a window I thought was kind of reasonable, like 0.1, then I got this beautiful histogram. So remember that your histogram depends on your settings. You might not want to use the automated calculator histogram because the intervals will not be something you would naturally pick. Either way, if you draw one and interpret it properly, that should be acceptable. Now we'll get to doing the mechanics. So one thing that we're going to need is our statistics. So I get all this data entered into a list, which I did for the histogram anyways. So then I just go ahead and do one var stats. And you should remember how to do that on your calculator. Should be stat, calc, one var stats. You can specify which list, especially if you named it. All right. So from this data, I can see my mean. I can see my standard deviation for my sample. It even tells me how many data points I have and my degrees of freedom. Now I still need a t-value. So how am I going to get that? Oh, I also need my standard errors on here too. And that is basically this S of X value right there. Okay, so that's your standard error. I'm sorry, your standard error is this value divided by square root of 20. That S of X goes up here where S is. Okay, so I still need my critical t-value. And I can get that with inverse distribution. And so I go second distribution. And then I'm going to go t CDF. It should be inverse t. I'm sorry, inverse t. Then I put in 0.975 because remember, everything to the left is going to leave out the 0.25 on the tail. I have 19 degrees of freedom. I hit enter and let it churn for a little bit. And I can see my value is 2.093024022. All right, so there's my critical t value. Then I can basically take this information and substitute it into the formula for the confidence interval, which would be the 9.845 times plus or minus my critical value times my standard error. There's some good news. Your calculator can actually do all this automatically. And if you go to Stat and Test, and you scroll down to t interval, and you can say data, so you don't actually have to put in statistics. Put in the list and the confidence level and calculate, and it spits out the entire confidence level for you, including your mean, and you can see the standard error for the sample and the 20, which is pretty much what I got. So I could have actually just skipped one var stats completely and gotten all my information from right here. So there's my confidence interval. Now I get to interpret it. Well, we are 95% confident that the machine dispenses an average of between 9.75 and 9.94 fluid ounces per cup. of coffee per cup. Notice we said the word average. We didn't say, we're not talking about individual samples, which gets to some temptations of how we might incorrectly interpret it. So don't say, for example, 90% of all the vehicles on Trip Hammer Road drive at a speed of between 29.5 and 32.5 miles per hour. The confidence interval is about the mean, not individual values. Don't say we are 90% confident that a randomly selected vehicle will have a speed between these two. Again, that's an individual value. We're talking about means. The mean speed of the vehicles is 31.0 miles per hour 90% of the time. Actually, the true mean is the true mean. It doesn't change. And finally, don't say 90% of all samples will have mean speeds between 29.5 and 32.5 miles per hour. Then when you're doing your confidence interval, that's the probability of capturing the true mean in your window, not where the samples are going to be. So we don't set a standard. One sample doesn't set a standard for every other interval. It is no more or less likely to be correct than any other interval.